With the rise of electric cars, and especially with plug-in hybrids, the action of putting a car on charge is becoming more and more common, and people no longer turn to look at how one of these electric-powered vehicles charges. There is some ignorance about this process analogous to refueling. In this video, we offer you a first approach to this car charging. But first, please like and subscribe to this channel, and then sit back and relax. Basic concepts. To better understand the differences between the different charging modes, it is necessary to be clear about what is power, which is measured in kilowatts, and energy, which is measured in kilowatt-hour. Other magnitudes also come into play, such as current intensity, measured in amps, and the difference in potential or voltage measured in volts. But for this topic, we can pass sideways. The power indicates how much energy is applied per unit of time, that is, how fast the energy is delivered. Thus, if we rely on the usual parallelism of water, the potential would be analogous to the flow. On the other hand, energy is precisely that, how much electricity we have. Therefore, 1 kilowatt-hour is the total energy that we obtain in 1 hour from a source whose power is 1 kilowatt. Similarly, to obtain 50 kilowatt-hour, we can be charging at 25 kilowatt for 2 hours, or at 100 kilowatt for 30 minutes. With this in mind, it is logical that when we talk about the consumptions of an electric vehicle, we refer to X kilowatt-hour consumed to travel a distance of 100 kilometers. Finally, and without going into detail, we could say that the intensity of the current indicates how many electrons pass by per second, and therefore, the higher the intensity, the shorter the charging time. The problem is that the higher that intensity is, the greater the section of cable that is needed to prevent it from burning. This is being one of the main limitations in home networks to achieve low charging times. To have a few orders of magnitude, in your house the normal thing is that the installed power is 5.75 kilowatt, not the contracted one, and the most capable circuit is the one in the kitchen with 25 amps. Types of modes of charging. Depending on the charging power, there are 4 charging modes, with their consequent requirements in terms of infrastructure and electrical demands, although only 2, 3, and 4 are used in electric cars. Mode 2. Mode 2 is the charging mode that we use when we charge the car using the cable with a flask or box that the manufacturer gives us, and that we connect to a standard Schuko plug in our house. This box is responsible for controlling the charging process, verifying that the ground connections is correct and that the charging powers is not exceeded or peaks are reached. The problems comes from the plug used, which makes it the slowest charging mode, about 2.3 kilowatt, since the current intensity is limited to 10 amps, so as not to overheat the cable since the charging time is quite considerable. Mode 3. Mode 3 is the mode that most electric car users will use, and it requires the installations of a charging point in your home, in which the previous control box is placed on the wall. The advantage of this system is that without a major electrical installations, it is capable of offering faster charging, in practice 7.2 kilowatt, although theoretically up to 44 kilowatt can be supplied, since a higher intensity of current can pass through its cable's current than by those of our houses. Before continuing with the last charging mode, it is time to make a small paragraph. The batteries of an electric car, like any other, work in direct current, and not in alternating current, which is what the plugs in our houses have. The difference between one type of current and another is that in the first, the electrons always go in a single directions from the negative pole to the positive pole, and these polarities are fixed, while in alternating current, they are reversed 50 times every second. So we could say that these electrons are vibrating. What does this mean? Well, to transform the alternating current with which we feed them into continuous electric cars, have the so-called onboard charger, which reduce weights and costs, is usually of that 7.2 kilowatt mentioned above. Mode 4. Mode 4 is the fastest charging mode, and this is because instead of using the vehicle's onboard charger, it is charged directly in direct current, obtaining this in an external transformer. Through this mode, we can obtain charging power between 50 and 350 kilowatt, but unfortunately, this type of charger is the least widespread due to the high cost that they have, in addition to the electrical connections that is needed to feed them, and that in certain areas, the electrical infrastructure will not be able to support it. 4 350 kilowatt posts are equivalent to more than 240 homes. Another inconvenience for the end user is that this type of charger is usually paid, with a kilowatt hour being charged at around 0.4 euro for the 0.1 euro we pay on average on our electricity bill. Connectors. Depending on the type of current and the geographical era, there are a total of 4 different types of connectors. In Japan and the United States, Type 1 for alternating current and CHAdeMO for direct current are used, but we are going to Central in the Europeans, Type 2 and CCS. However, although the industry is moving towards adopting the European standard, vehicles like the Nissan Leaf sold in our country use Japanese. The Type 2 charger is capable of supporting a maximum power of 44 kilowatt, being used in charging modes 2 and 3, and therefore compatible with single-phase and 3-phase alternating current charging. We can say that the CCS is an evolution of the latter, to which 2 more terminals have been incorporated in its lower part of its prodigious size, and which are responsible for that continuous current reaching a supply of 350 kilowatt. Going back to Type 2, we will find the terminals L1, L2, and L3 that correspond to the different phases, and the neutral so that the current returns, in addition to the ground terminal. On special interest are PP and CP terminals, the first being in charge of communicating the car with a charging point to indicate the power and given the OK to start the process. As for the proximity terminal, it is one last measure of security, its length being a little shorter than the others, so it is the last to connect and the first to disconnect. Induction wireless charging. However, the future of charging electric cars is shared with the already present charging of smartphone or smartwatches wireless charging. Thus, by eliminating the cables and connectors, we save ourselves compatibility problems, the hassle of having to unwind the cable from the trunk, or the unsightly and dirty drag of dragging them along the ground on a rainy day. To do this, the ideal is to install a coil in each parking space along with another in the car, and by electromagnetic induction to charge it. It is the same principle as in an induction cooktop. An electric current is passed through the coil on the floor, which generates a magnetic field, and according to the Faraday-Lenz law, an electric current will appear in the coil of the car, which tends to counteract this generated magnetic field. And it occurs with the kitchen pan. An increase in temperature also appears, which in this case is undesirable. If you enjoyed this video, don't forget to hit like, the subscription button, and the notification bell. To get notified when new videos are uploaded from this channel, please share your thoughts about charging an electric car, the concept and types of electric car chargers in the comment section below. Thank you.